Assalamu alaikum. Good afternoon. Can you hear me? Assalamu alaikum wa rahmatullahi wa barakatuh. It's a pleasure to meet you again here. I have a nice session for you. It's actually about AI competitions. Yes? It works? Yes. It's about AI competitions. Actually, AI competition has been an essential, maybe, part of my learning journey in AI. I remember when I started AI, maybe just 5 years ago, I just started maybe studying math for 2 years. I don't like AI, nothing else. Maybe just after 2 years of math, I found there's something called AI. Oh, and it contains math, so I just joined. But I remember when I started AI, I actually didn't have any experience in programming before. But maybe there was a local conference in Sudan, I guess. They just presenting some stuff like transformers, I don't know, encoders, this stuff. And I swear I didn't understand a single word. I just attended to eat something good and get some coffee. But at the end of that conference, actually there was, I remember, a competition in AI. I just gathered my friends and told them, let's join, it's my first time. And my friends as well has no experience. And we have some very significant skilled guys who are in that conference and participate in the same competition, I guess. So I just kept copying from the internet without understanding anything until the 3 days passed and found myself in the first 2 days. So it was actually very motivating after I think I won that one. I think then maybe for some reason Sudan stopped for I think 2 months, no internet in Sudan. I just kept maybe reading about Andrew Wingy, the courses. Maybe then in March, in the next March, maybe after 3 months, there was a very huge competition in Africa, I remember. It was around all Africa. That was only in Sudan, in that conference, so it was easy, but this is a harder one, of course. So I think at that time, before the competition, before 1 month, I almost maybe forgot everything about pandas, machine learning, and this stuff. So I just kept that month just revising all these basics, and I believed that for sure, given I just got the first place here, I'll get the first place here. It's very easy, and overall Africa, what does that mean, So I just joined, and mashallah, there's a guy called Azra, I guess, from Tunisia. He did some bloodbath in the leaderboard. I think there were 3 tracks: beginner, intermediate, and advanced. He joined the beginner, and one day he got the first place. He joined the advanced, and the first day got the first place. He joined the intermediate, and maybe he couldn't find enough time and just got into 10th place, I guess. So he was the first in Africa, and he was very, very skilled, And I think I just came the 40 or something. I think after that, just due to sadness, maybe I gave up AI for 1 or 2 months. Then again, I just came and revised all the principles. Why did I lose in that competition? I just read more about data, and it turns out that competition was time series data, and I was just considered as tabular. So maybe for 1 or 2 weeks, just revise that principles, learn more new skills in that type, and try to do that competition locally, and found myself in just 3 hours could get the first place easily. If you notice the flow here, it's not about just the competitions, but about the learning you are getting from these competitions. After each competition, you just get a next level skill, maybe, in the topic you are considering this competition. For example, time series. If you join the time series competition maybe for 1 month, you will be implementing time series codes for 1 month. So the difference in skill before and after is just incredibly significant. You have no idea how much this will improve your skills. Okay? So I just kept from that time joining competitions in different parts of AI, tabular, time series, maybe in NLP, computer vision. I think for the tabular and time series alone, I joined more than 20 competitions that time. Then maybe after several months, I just started learning deep learning, NLP, PyTorch, but was not skilled. I was just copying codes from the internet, from GPT and this stuff. Then maybe until I started KAUST Academy, maybe the last year, I think I was in the 2nd stage, I just started learning PyTorch and computer vision. So actually, I was explaining to the other students the computer vision and PyTorch in videos, but I had no understanding for this at that moment, so I just learned it from the same program يعني. فالحمد لله then يعني I just kept going from each competition to other. After I just went now alhamdulillah through most of the topics. Maybe we have tabular, we have time series, we have vision, we have NLP, we have the competition system and ranking, we have biology, we have I guess there are some custom problems, there are some LLM problems, there are some matching problems. So you find yourself knowing most of يعني, the recent architecture, the state-of-the-art architecture, the best practices in each type of these fields in an enjoyable way. Okay, you are competing, but in the same time you are learning very recent knowledge that actually will help you a lot in your career يعني, in AI. Okay, so that is why very useful, and I'm still competing يعني. So that's why I'm presented here. How to win this competition? Actually, in these slides they are a bit long, so it's up to you if you want to stay up to the end of these slides. But I think it's mandatory up to 3. So after that, if you want to leave, it's up to you. But these slides are a bit long. I actually summarized everything I know in the 3 years in these slides, in terms of the competitions themselves, in terms of the ideas you should employ in each problem, and also in terms of if you have a real world problem, how to formulate this problem as an AI problem, how to choose the best models, okay? Then maybe at the end I'll maybe talk about a bit of the career options in AI. Then we have a small surprise كده. Okay? So let's start. Firstly, do you know about Kaggle, right? I think anyone who did AI should know a bit about Kaggle. Kaggle is actually maybe the best platform or the best community for AI. It contains everything you might need, and it contains, aside from just competitions, it contains a lot of tutorials, a lot of notebooks, a lot of discussions, data sets, models, tutorials. It's I think the best place to learn about the practical part of AI. Aside from the courses, in the courses you are actually just be given theory and maybe بدون but just maybe some minimal lab, 1 hour lab actually, and you should just maybe fill the gaps in this lab and just try to understand line by line and maybe skip يعني. But here maybe you will be given a competition or a problem, okay, and you will be given, for example, 2 months to work on this problem. So if you have zero understanding of the task you are doing, actually you will maybe spend 1 week understanding the task, understanding the general codes for this one, then maybe for 2 months you will be spending your time just improving this code. And to improve this code and to win also the competition in SS, you have to learn the code well. You will properly learn about the theory as well. You have to learn the best practices. And in order to compete against those in other countries, they are international competitions. They expect participation from everywhere. So in order to beat these guys, you have to learn the state-of-the-art techniques. So it's not just competition, but it forces you to learn the state-of-the-art of everything in AI, and it will give you some practical skills. I don't think you will learn them from some courses. Like I think one of the most important skills you will learn in Kaggle is how to evaluate your model properly. I think mostly in most of the education here, or maybe generally in most of the courses in AI, they just do train to split 80%, 20%, and call it a day. Okay, but actually it's incredibly more complicated than that. This is a very, very toy setup. I'll just present some examples later, but this is a very important part of you learning Kaggle. And it's very fun to compare yourself against the tops in the world. I remember one time I was in the public leaderboard. I think I was in the 3rd place, and the 4th place was just the first in the world. It's sitting there. I didn't just actually get the رموني تحت, لكن it was a nice moment to be here, and the first in the world is just below you So it's very fun to actually, because maybe you could be able to get some ideas that is very unique to the extent that you could really win a very, very good prize and get in the top in the world. What is the problem? It's okay to get the top in the world So, and it's fun it will be addicted a bit So this is what you will hear in social media. But anyway, let's go into a bit in the competitions. In the competition, you will be given a real world problem. It might be in any domain. Maybe it's finance, it might be medicine, support, sports, astronomy. they are real world problems. There are companies who actually has these problems in their company. I mean, they have data, but maybe they want solutions of some problems they have. And if you thought about it, you can, for example, maybe hire some data scientists to work on this problem. But in the same time, you can, for example, host a competition in Kaggle where the top of the world will work on this problem. If any of them manage to make a huge breakthrough in this competition, then it's very useful for you. So that's why some companies host these competitions. But on the other side, for you as a participant, actually, in order to solve this problem, you have to learn domain knowledge about the problem, read about that, choose the model, and try to solve the problem and get in the top of the leaderboard. And in order to do this, you have to learn AI, practical AI. And that's, I guess, the best part of it. It's actually very simple to the setup you are seeing by far. It's that we have the data, train and test data. They give you the train with the labels, and you should train your model using this data. And you should validate your model by your own data, and then you will submit to some sort of a leaderboard. Okay. In this leaderboard, what you will submit is, after you train the model, you will make predictions on the test set they gave you. They will not give you the labels, and you will just make predictions on this test data. And for example, if this is a data set and you want to predict the price, for example, there is something called public leaderboard and private leaderboard. Okay, in the public leaderboard, all of these are the test predictions. Okay, the whole column is the test prediction. The test itself is divided into two parts: public leaderboard and private leaderboard. While the competition is running, you will be evaluated based on the public only. You will not, the score for the private will not be showed. And then maybe after the competition finish, they will show the private leaderboard and will give you the final results. But why do you have to divide it into these two leaderboards? And why do you have to divide the test into two parts? Why not just evaluating on one part? The private leaderboard actually maybe is important because you might be overfitting to the public leaderboard. If you had a look in the right part, the prediction actually aligns well with the public leaderboard, but in the private, you are very far. Okay? That's an indication of overfitting to the public leaderboard of the test set. So unless you ensure your model is very good, is not overfitting, okay, you will actually fall down in the private leaderboard. And that's actually the best part. You have to evaluate your model very properly and in a real world setup in order to ensure you are doing good job here, okay? And actually when the leaderboard, private leaderboard get all over the place, and when most of the guys are actually overfitting and they fell down in the private, we call this shake up. It's like just put the leaderboard and it all. Next is that why do we need these conditions? What are the goals? What should I optimize for? Most of them actually, in concerned about the performance, give me the highest accuracy. Okay, and this is actually very good because it's objective. Just get the higher accuracy and you will get the price. Easy. Well, not easy, but I hope. Then you have the efficiency. They actually put a lot of constraints on what you are doing. Many competitions now, for example, ask you that you should do the inference, predicting the test, in less than 9 hours, for example. Or using only maybe a 16 gigabyte GPU, for example. So these limitations actually forces you to use smaller model but more smart techniques. And sometimes they have huge data set. I guess one of the competitions had more than 1 terabyte of data of medical images, so you have to handle that. You need GPUs for that. And how you are supposed to train a model using 700 gigabyte of data. Actually, this you will learn by handling such competitions. You will learn how to handle big data in an efficient way. You will know how to let it in your model fast enough, how to do inference later fast with this amount of data. There are a lot of techniques in this to learn, and this actually aligns somehow with what you will see maybe in industry, where they want smaller model and that gives good performance, but at the same time you have a lot of data to train, we want them a bit small, other things. Sometimes you have to gather the ideal data set. Sometimes the data set itself is not available, or maybe they give you a subset or maybe small amount of data, and you are supposed to generate more data by yourself or to gather more data by yourself. And this is very interesting. You will learn how to gather data by yourself, and this actually aligns as well with many of the projects you'll see in industry. And avoid overfitting. It's actually, I think it's it gives you a really good mindset that you will not find in any other courses. Yani. You will be very cautious about not overfitting on the public. You will set up your validation properly, and yeah, a lot of good things. Yani. So let's grab it. Before going inside, I just want to explore it a bit as a website. They actually have many parts here. They have the competitions, they have this set, models, codes, and other stuff. In the competitions, there are international competitions like these ones. Obviously, this is incredibly easy given the price. It depends on the problem. There is a problem like this one. I think it's mostly time series. They give you data of these sensors and ask you to predict what is the gesture this guy is making, for example. So yeah, it's interesting. It's time series data. So nice problem. Let me take it as an example. So yeah, they have different sections here. They tell you about some domain knowledge about the problem itself. They tell you about the evaluation, how we will evaluate your model, the timeline, how much these conditions take. Actually, usually they take 3 months, and I think this is a very good period because, for example, it might be totally new for you. It's not just easy classification problem. Yeah. It will need a lot of ideas for you. It might need new architectures, for example, employing some of the state of the art. It needs handling a lot of data. 3 months is actually a perfect time. You might be saying it too much, but no, it's perfect. If you, for example, spend 2 weeks trying to understand the overview, the problem itself, and try to understand the public codes, okay, and then try to add your ideas. If you kept adding your ideas, learning new architecture, keep adding new ideas, learning new architecture, after finishing these 3 months, you will find you just had a significant step forward in your skill. As I mentioned previously, you don't know how much this jump is. It's very, very huge. If you just work on, for example, 3 or 4 competitions, for example, for vision, you will mostly know most of the architectures, know how to implement them, what is the best practices for them. So it's really, really, really rewarding. And there are some prizes if you skilled enough. They also mentioned the data, for example, here they present the data, everything here, train, test, I don't know. Let's go to the leaderboard first. In the leaderboard, they have the scores provided here. You can go as solo guy or maybe in a team, okay? And this is the public leaderboard. They say the public leaderboard consists of only 42 of the test data. Then after the competition finished, they will present the private, okay? Which maybe you will be overfitting or not, okay? Depends on your model, but sometimes huge shakeups happen. If you just had a look here, and maybe old ones like this one, not this one. Maybe this one. Let's check the public. The public is here, mashallah. This is doing very well, giving maybe a 50% accuracy, I guess, or something. It's not that good, but given you are seeing a lot of participation here, and he's the best in the world and getting only 50%, it means it's good, last. But what happened in the private is it went all over the place. This guy actually came from the 1,488th place and just jumped to the first and got, I think, $10,000. It's not lottery, it's not by luck, but these guys actually worked very well on their evaluation. They worked very well on how to split their data, how to evaluate the model, and made proper choices. But for example, these guys actually keep submitting to the leaderboard and just tuning the parameters based on the leaderboard, So they somehow overfitted to the test data. So it's not luck, it's actually skill mostly.
One question.
Yeah.
So how many solutions can be submitted? Okay, the question is, for example, if I have, you said they did really good job, but their metric from the public data set was quite small.
Yeah.
And let's assume they have some vast model, but it gives
better results
in the public data set.
Yeah.
Do they have a chance to submit to both of them just in case maybe?
Yeah, sure. You can make a submission as much as you can, but at the end you have to choose only 2 submissions.
2 submissions.
Yeah, and it's choosing submissions itself is actually very challenging. Sometimes we choose the one that gives the best validation score and the best leaderboard score. So you ensure if you are not overfitting to the leaderboard, then you get the best leaderboard at the private. But if you are overfitting, you have a backup plan where you get the best validation score, which is not good in public, but it might go up in the private. So yeah, it also has a lot of ideas here. But anyway, we have the leaderboard, as I mentioned. We have the public, we have the private, we have discussions. Actually, this is maybe the best part of Kaggle. In all the competitions, you will find a lot of discussion, where the best guys actually put a lot of knowledge here. They basically explain the whole domain knowledge you might need. They give what models might work. They actually discuss CV versus public leaderboard. It's like with the validation score against the leaderboard. Is it good? Is it not? Okay. They sometimes discuss some weird behaviors, some weird sequences. They did EDA and check the sequences. Maybe they didn't work. It did work. Why this happens here? Just reading the discussion itself is actually very valuable. You will learn a lot by just reading through the top guys in Kaggle. So yeah, and we have in the codes actually a lot of baselines. So if you want to start, you don't have to write everything from scratch. There are many codes here. There are code for EDA. There are code where people already provided baselines. It's not good score, but it's something you can just copy and try to build on. Okay. This actually helps a lot if you don't have a background about this topic. You can just copy one of these notebooks, maybe spend some time reading it, understand it, and then try to improve it. Okay, and I think this is very good part, the code and discussion, because having a community that can actually answer all your questions about the problem, offer you good codes that can actually you can start even problems that are incredibly hard. You will always find baselines you can start on. This actually helps you start any type of problem, whether they are hard or not. Okay. So yeah, it's fun, and actually there are some also ranks for the players. If you can see, there are gold medals for the first 1%, silver for the first, I guess, 5%, and I think bronze for the first top percent. Yeah, you can acquire these. If you acquire these medals, you will be promoted in the ranks they have. I think they have ranks of master. They have novice, contributor, expert, masters, and grandmasters. It depends on the medals you are getting, and it's actually incredibly hard. As you see, the master, the expert actually require only 2 bronze, and there are only 10,000 in the world. The master require 1 gold and 2 silvers. There are only 2,000. The grandmaster required 5 golds, which are incredibly hard. I mean, 5 golds mean you are in the top 1% in 5 different problems, 5 different competitions in the world. So getting to this level is actually means you're already incredibly skilled. Check this guy who has already 38 gold. Mashallah. He does have any bronze. Mashallah. Anyway, you have the competitions. It's very hard to go into these rankings, and somehow, given there are only 300 in the world, so it motivates you to go to this extent. Have you checked the first in the world, this guy? Actually, this is not his image. He's much younger than that, but he's putting this image. But as I mentioned, there are many tiers. There are expert, master, grandmaster. A lot of info here, but it's fun, and it's really fun, and it's actually has some prestige or recognition, if you manage to get to these models. It also means you are very skilled in.
How do you know if you're overfitting the data?
It depends on your validation. How have you split your validation properly? Just splitting into 80% and 20% is actually very trivial. There are a lot of other splits that actually, in the same way that split it train and test, you should split train and validation. Okay, and doing that is actually not easy. Because how did they split the train and test? This itself needs some EDA, some exploring for the data itself in order to know that. Then you can mimic that in your setup. Okay, then I hope after that you will not be overfitting. So there are many datasets. If you are searching for datasets for your problem or something, you want to build something, you will find a lot of datasets here. The codes, the discussions, and I believe even the learn. In the discussion, you can search as well for any topics, and you'll find tutorials, not only these are not codes just for the competitions and call it a day. No, for example, if you want an explanation for diffusion models, for example, you can search for diffusion model, you found very, very good notebooks explained there, okay? Okay, that's it, I guess. So maybe you want to join. These are international competitions, I guess, and these below are actually some community competitions were hosted by non-big companies. Yani. Last point is, I think this is maybe the best part as well of Kaggle, is that after each competition finishes, the top in the world, all of them share their solutions publicly. So if you joined any competitions and maybe spent three months on it and just came at the end and looked at the leaderboard, you will find that all of the tops actually sharing their solutions, okay? And this is actually very, very, very beneficial. Yani you will find what models they did use, what tricks they did employed, yani. And yani, imagine just you worked on a problem for 2 months and it was very hard, yani. You did all the best and you just went into silver, okay? But after the competition finished, the first one shared his solution, and you will find some very, very interesting techniques, some new knowledge you can learn from that. Then come and enter the next competition where actually has the same data type. You will find yourself in the top mostly, okay? So yeah, it's very, very interesting. Actually, you just learn the AI by reading these stuffs. So yeah, it might be very, very, very nice. Yeah. So let's return to our slides. I'll talk a bit about the toolkits you are using in AI, then maybe about the formulating the problems and this stuff. If you have any questions, you can interrupt me, it's okay. Firstly, the data types you have actually, these types usually in AI, tabular data, time series data, waves, text, images, and videos. Each one has its own pre-processing step, each one has its own models you can use. Let's start by EDA as the first toolkit. EDA is just the exploring the data, okay? What do you mean by exploring the data? This is a very important question. Should I just make some nice plots and call it a day? Actually, you need to explore the data, firstly to get comfortable with the data. You should understand the data itself and ensure the data doesn't have serious problems. For example, you have a column of age, okay? And you were training the model for the whole month and it was not giving good results, okay? And all of a sudden you just tried to look into the column of the age and found most of the columns are more than 200, okay? It doesn't make to have age of more than 200, for example. So there are some mistakes in the data. So how to capture these mistakes is actually incredibly important. You have to explore the data, understand how the data was generated, and in order to get more ideas. And if you need to do that, you will start to have more ideas how to improve it further, okay? And determine how to approach the problem. I guess I remember in one of the competitions they have biology sequences. It's just sequence AS, SS, Madri, 200 characters. And in addition to this sequence, they have another table for each sequence. They have a table that has some data about this sequence. For example, which family does this sequence belong to? I don't know, temperature, something like that. Okay. How people approach the problem? Firstly, the top solutions actually, they took the table and trained a machine learning model. They took the sequence, okay, split it by character and trained an NLP model. They took the sequence and put it into a model that converts the sequence into 3D characters, okay, 3D structure, and built a CNN 3D models. They made the three. So, it's incredibly amazing. And when I said the first time, it was really amazing. How he did think about that. It's just a sequence, biology sequence. Usually we deal with that in NLP. How he did converted the problem into CNN and converted the problem into tabular data and managed to measure all of them as well. So you will find very, very innovative ideas. Next thing is how to split your data. CV is just for cross-validation. It's how to choose the best validation for your problem. It actually totally depends on the problem and EDA you are doing. Okay. There are some other stuffs that determine the most important features. There's the machine learning models. If you heard about something called gradient boosting algorithms, they can do that. And as I mentioned, determine some strange behaviors in the features. Discover some serious problems with the data, or what we call leakage. This is very important in industry, I guess, because if there is a problem in how you are dividing the train and test, and somehow some labels of the train being leaked into some labels of the test somehow being leaked into the train, okay, and you trained on this train, you will get very good accuracy because you are leaking some of the tests. But if you try to do that in real world, you will find the accuracy very bad. So we call this leakage, and it's not easy to discover leakage. It's actually hard, and it's, I think, a bit of a skill يعني هنا. But later. And some fine magic features. Sometimes if you dig it enough, you will be able to extract features of the feature engineering that's actually very valuable. But a lot of details. But let's see some examples about C strange behaviors in distributions. Have a look at this distribution. Anything looks weird يعني? What information you could get from this one? Long tail, what does long tail mean?
Most of the data, the values of the data are zero, except some very few values.
Sure, it's cool. Outliers. When you see a long tail, then that definitely.
Those values must be removed.
Not necessarily, it depends on the task, but yeah, you can say that. Okay, but what does this tell you? There are some outliers here. Okay, so but it has long tail to the right. Sometimes when you have long tail on the right and you want to do EDA on this, sometimes you take the logarithm. Okay, so I just came to this data and just took the logarithm and got this. Any problem? Yeah, this vertical line. Okay, what does this vertical line mean? Yani? What do you think? I don't see an outline. Vertical line means you have a lot of values, huh? You have a lot of value. You have a specific value repeated quite a lot of time.
Maybe it is data clinical data.
Yeah. Actually, this is a very important indication. This might mean that this exact histogram, I take it from a competition where there's a histogram of feature like this. Actually, it turns out that this feature has a lot of missing values, and all of these missing values has been filled with the mean, and this is the mean. Okay, so you can infer from this one that they have a lot of missing values, and for example, they just filled values with the mean. I just removed the missing values, yani took these values and returned them to missing values, inputted them into my model to predict them, yani, and actually got much better results. So have a look at this column. It looks very nice. Do you see any problems? Yani, from here, I don't think so. Right? It looks like a continuous column, right? Continuous column, right? Right? Let's plot the histogram. Okay. Okay, this looks continuous. I don't think so. Okay, this looks like a discrete column, right? Yani it should have two values, but when you just look into the raw values, this maybe continuous column. But if you draw the histogram, you see something like this. Okay. Actually, this was very interesting. In one of the competitions, the host wanted to anonymize the whole data because the name of the features themselves, if they got leaked in the internet, I think he will lose some advantage against his competitors. He's a company, I think for, I don't know, finance or something. And the information they are using for building their models, they don't want to leak them to the public. So they hosted a competition and anonymized the whole column names. They make the columns A1, A2, A3, A4. Okay, and for the values themselves, actually, they firstly converted all the categorical values into numbers, encode them, then normalized the whole values. So even if the value is actually continuous, they normalize them. Then they add noise. So it's almost impossible to get back the original data or the original values. So the Kagiras, one of the top Kagiras, actually tried to reverse this process. Okay, he tried to block the columns and found this. He actually zoomed in into the top of the columns. He found this. Okay, looking just into this, you will directly know that there are noise. There's some noise has been injected. And if you rounded this value to 0, rounded this value to 1, okay, you will get the original values. Actually, by adding noise, you will convert everything into float, I guess. Okay, so when you are doing this and rounding, you will get them as integers, which is more efficient. The original data was 50 gigabytes. After he managed to reverse all of the columns and retrieve the original data types, he reduced the size to only 5 gigabytes. So it was incredible. So yeah, it was a very, very interesting finding. So yeah, EDA is very important, but it's a skill at the end. Okay. There are many other examples. Maybe I could go into this one. This competition where you should segment what actually gets out from the airplane. Okay, you should segment these lines. So it's a segmentation problem, but it's first solution, less solution used unit with max bit encoder anytime. The real point was this one: discover the 0.5 pixel shift. He found a very interesting insight where when he used the augmentation of flipping, it should work. You are just flipping the image. It should almost always give you better results. Okay, but they discovered that when they use flip or rotation, they actually get much worse results. Okay, they did a lot of EDA, and at the end they found out that the labels themselves that being provided by the host are actually shifted. Okay, everyone who fixed this shifting managed to get into the gold place. So doing good EDA is actually incredibly important, and it's really fun. If you just imagine you are the only one, maybe you found this in the leaderboard, okay, and you are getting, maybe you could get very high gold easily. Okay, even this one, if you look into the leaderboard, you'll find something even more interesting. In the leaderboard, have a look at the scores. Okay, 60, 60, 60, 60, 60, 60. 60, 60, 61, 61, 62, 60, 68. What is the problem here? There is a huge gap here, okay? Even below, if you went below, 69, 69, 60. There is a gap here. Actually, there was a trick where a specific feature, if you just do one hot encoding on this label, you will directly go into the gold. And only these guys just discovered this trick, okay? The only top 18, and they managed to get the gold. Easy. If you just did proper EDA, you might actually be winning this competition. So yeah, it's fun. There are many techniques to do EDA. Actually, you see the plots, the TESNI and UMAP. They are very fun. Actually, you can visualize high-dimensional data. The tree models actually help in detecting important features. If you have a model that's predicting, for example, the price or something, and you want to know which features are the most important to predict the price, you can use the tree models. There are a lot of details here. Each one of these has how to use it, which one is better. A lot of details here. But for example, for the tree model for detecting the important features, this is very interesting in knowing which features are important if the data itself is anonymized. Like the problem I mentioned before, we don't know the meaning of the columns, but we have columns. If you just fitted a model into the target and looked into the feature reporters, you will directly know the models, the features that are actually important compared to the other, without even knowing their meaning, okay? Which is very interesting. How to choose the best features or worst feature, remove them. We have several techniques, something called LUFO, SHAP, repetition importance, and there's something called adversarial validation, where it's if the train and test have different distributions, okay? This is called distribution shift. I will not go into details, but each one of these actually have, I can remember a competition where I used this one, and it was useful. But if one of these, I guess, is important as a toolkit if you are doing EDA. I just want to go into next part. Some nice guy actually went into the data. He trained the neural network. He went into each layer, okay, and extracted the features, okay. He applied TESNI, and for each ebook, okay, he extracted features in each ebook and applied TESNI, okay, and showed it as a view, okay. So this is how the model was learning to classify between the red and blue after each ebook, okay. It's like they were like this, and I think we are trying to get separated. So what you are seeing now is a neural network that's trying to classify between these two, yeah. Which is very funny, yeah. Okay. This is the full image. I think you already see this before, the TESNI for the nest, okay. Next step, maybe after the EDA, is the pre-processing. It totally depends on the data. If you have table and time series, these are the most important one. Encoding, maybe converts categorical features into numerical features. It has a lot of types: label encoding, one-hot encoding, frequency encoding. There's something called target encoding, and they're very useful. There's something called feature engineering as well. It's derive features from the original features. And in tabular data competitions, feature engineering is actually the most important thing. It will give you a huge boost if you manage to do it properly. You have feature selection, as I mentioned. Normalization, maybe not. It depends on the model you are using. If you are using any model except the Gaussian boosting, you need normalization. The Gaussian boosting models in machine learning don't need normalization. The text data and image data, image normalization, augmentation, cleaning, normalization, maybe you'll see it later. But in terms of the validation, as I mentioned, splitting your data into train and validation is very important. You should mimic how the train and test is split, then try to do that in the train validation. Okay, doing that itself is not always easy, especially in Kaggle. It's not easy, and if you manage to do that, then I think this is a very good competition. But mostly it's hard. I'll just go through the type. The first one I think everyone knows is hold out fold. It's just split into 10 and 20 randomly. And shuffle the data and stuff. It's good, but in reality, no one uses this. Okay, except maybe in LLMs. If you are training LLM, it might take more than 24 hours to train if you are just fine-tuning into some data set. So given the long training time, I might use 80, 20, but generally everyone uses k-folds. Okay, it's like divide the data into 5 parts. Every time train on 4, validate on 5, the 5th, and predict for train on 4, validate on the 5th. But what happens here is that you are dividing data randomly. Okay, what does that mean? That does mean if the target, for example, if your data has 100 positives and 1,000 negatives, okay, you have 100 positive and 1,000 negatives. When you split your data randomly, you assume when I take this model and employ it in real world, okay, you might have, for example, 500 positive and 500 negatives. Okay, the ratio of the distribution of the target in the train is not necessarily the same in the test. If you are applying k-fold, you are assuming that. But on the opposite, if you use stratified k-fold, okay, you assume that the same distribution you have in train will be in the real world later. For example, we don't have a lot of cases, for example, for cancer. Maybe out of 1,000, maybe we have 50, for example. Okay, so this is what you have in the data set. Okay, and you expect the same ratio that only 50 against 1,000 will be as well in the real world. So in this case, if you want to save the same ratio, usually use stratified k-fold. You will be mimicking the ratios along each fold. If you notice, each fold has the same ratios, but in the k-fold, it doesn't necessarily do that. But anyway, if you are doing a classification problem, usually stratified k-fold is your choice, generally. There's something it's called group k-fold. It's when there are some specific groups are in the train, not in the test. Assume you are training a model to predict some prices of houses, for example, in Saudi, and you have data from Abha, Jeddah, and, for example, Riyadh. Okay, and you want to predict Sharqiya. Okay, so you have the area in the test is different than those in the train. Okay, so if you just train, dividing your data training,
Because by 1 minus something, the value that we have. By taking the opposite.
You mean how? I mean that we have a data set, for example, maybe 1,000 samples. Maybe 250 has been retrieved from Riyadh, okay, and 250 from Abha, 250 from Jeddah, 250 I don't know from where. But in the test we have 250 samples, but from a different region. Okay, so the point is, if I just splitted this 1,000 samples I have randomly, I might have samples in the train as in Riyadh and in the validation as in Riyadh, right? But in reality, the area or the region in the test is actually not exist in the train. Okay, so I want to mimic that. In order to mimic that, I'll use group k-fold, which actually I'll give in the region as groups. So it will put all the regions in the train different than those in the validation. So in the train validation, for example, it will put Riyadh and Abha, and in the validation it will put Jeddah. Okay, this is the first fold. In the second fold, it will put Abha and Jeddah, and validation will be Riyadh. In the first fold, it will put Jeddah, Riyadh, and validation Abha. This way, all the regions in the train are different from those in the validation. I mimicked what we have in the train test, where all the regions in the train are different than those in the test. Okay, I hope it makes sense. Does it make sense? Okay, I'm not really used. Okay, I split it. I have my.
So we can connect this board.
Okay. Let's see now. I think it works, yeah? Yeah, I think it works. Thank you. I think it works, yeah. Anyway, imagine this is your train, okay? You have in your train you have three countries, you have three regions, for example, يعني أبها, come on, أبها, you move Riyadh, you have, I don't know, Jeddah, for example, okay, and you want your model to generalize to new regions. For example, in the test or in the real world, you want your model to work, for example, on, okay, X for instance. Now, I just want to mention because it's region, so Sharqiya, okay. Assume it's Sharqiya. So in the test that the countries here are different, okay, the regions are different, okay. So if I want to split the train data into some train and validation, okay, we have here train and we have here validation. The group K-fold tells you to put in the train Abha and Jeddah, and here we have put Riyadh. ليه or why يعني? The reason is that we are using in the train regions that are different from the validation. We are mimicking that the regions here in training are different from that in the test or in the real world. So I hope it makes sense. Yeah. It could be also seen as, for example, the patients. Assume you have a lot of samples where, for example, each 500 samples belong to one patient, okay, and you want to apply your model to new patients later, okay. So the patients in the train should be not the same as those in the validation. So in this case, you have to put the groups as the patients. Does it make sense? Okay. Right.
So it's like to build a cluster.
Yeah, they're called groups. So it's like this.
Which one is yours?
I think the left one.
No, right. The connector.
Right. Yes, I think the left one. Yeah. Okay. So this is the group K-fold. The last one is the time series split. It's only in time series. Is that imagine you are training your model on data from 2015 up to 2025, and you want to predict in real world. They ask you, please, you have this data for the last 10 years, and we want to predict, for example, the demand for our company in the next year. Okay. So we have time here. So in the time series split, it basically tells you for the train in the first fold, for the train on, for example, 2015 and predict 2016. In the second fold, train on 2015 and 16 and predict 2017. In the third fold, train on 2015, 16, 17 and predict on 2018. Notice that it just depends on the time. We split the train and test based on the time. Okay? Does it make sense? It's time series split. And sometimes combination between them. We have stratified group K-fold, we have group time series split, so it's basically, if you just knew the properties, you might sometimes want, the same ratios as in the train, but you have different patients in the train than in those in the test, so you use group stratified K-fold, for example. It usually depends, but you will not learn them really by just looking here. But if you just implemented these things, try several conditions, saw these all types, try them by yourselves, you will find each one of these is actually totally different from the other. Okay, but yeah, it's just for interest. So a good question here is how to know if your score is good or not. Okay, here what comes is actually baseline. You first train your model with any parameters. Okay, with just a good validation, correct validation, but with any parameters, and you have a score. For example, 90%. Is 90% good or not? You will just set that as a baseline. Then you will try to improve on that. Okay, this is your baseline. You can infer that from the leaderboard. If you enter the leaderboard, you'll find, for example, all of the guys have 90% accuracy, and you have 50%. So your accuracy is bad. But if you went to the leaderboard and found all the guys have 55%, and your score is 50%, then your score is good. Okay, so how good or bad is your score is actually depends. Okay, depends on how hard or easy this task is. Okay, does it make sense? Optimizers. We know the optimizer in deep learning have categories in the sense, categories with momentum, RM-SPOB, Atom W. I think even we have something called soup and we have something called shampoo. And it actually works very well, but they are totally new. Which one is the best? Atom W. Are you sure?
You told us.
Yeah, AdamW. Yes, AdamW is the best actually, because it's even used, I think, in most of the default libraries, it's actually used as the default AdamW.
Not always.
Always.
If you sometimes if you take the FGD and choose the parameters wisely, you could get better results.
Well, I could try that by myself, but from experience, I didn't ever find anyone get better than AdamW, except maybe in very specific cases, but I can't generalize on that one. Okay? Schedulers, you know schedulers, right? It's when you start by a high learner rate and try to decrease it up to as you go to the end. You know it, right?
Yeah.
Sure.
Yeah, we saw it with you.
خلاص generally I want everyone to understand it. I think I explained it previously, but that imagine you lost your phone. If you remember this example, imagine you lost your phone in the 10th floor and you are in the first floor. In order to go to get your phone, okay, you will start by high speed, okay, and as you approach your target, as you approach your phone, you will decrease the speed, right? Right? So yeah, it's similar here. Schedulers, it start by high learner rate, then decrease the learner rate as you go, okay, up to reaching the end. It actually helps significantly increasing the convergence and getting best results. If you are not using a scheduler in your code, 100% you are leaving a lot of the performance on the table. Okay? So we have many types: linear, where it decays on linearly; exponential, cosine, polynomial. We do some plate. It's whenever the loss gets stabilized and not improving, reduce the learner rate. This is called reduce on plate. So the best one is cosine. Are you sure? Cosine?
Not always, but sometimes.
Cosine, always. It's always the cosine, and even this one, if you look into most of the common libraries, you will find the cosine actually is the mostly used one. Up to you, you can try, but yeah, that's what I found. Okay, this is related to the training stability about the parameters optimize the scheduler website, how to tune them properly. I already explained this in the Sunday session, if you remember. We talked about this extensively. You can return to that one if you want, but this is very important. Trainer stability is incredibly important to have well. Next, you have this efficiency. For example, if you want to improve the speed of your model, it depends actually. But for example, the data processing, we have something called, we have pandas actually. You know pandas, okay? There's another library called QDF, CUDA data frame. It's by NVIDIA, and it's pandas but works on GPU, okay? Why this helps? I had a competition before. The data is around 50 gigabytes. It's actually around 13 million rows, and I think 200 columns. 13 million rows, yeah, and 200 columns. If you use pandas, okay, in order to do the data pre-processing, I think it might take 2 or 3 hours to finish. Only data pre-processing, no models trained. Just running pre-processing, and very, very simple stuff, okay? So in that one, I had to use QDF in order to convert all this to GPU, and it finished, I think, in 10 minutes. So which is very, very useful. Polars is actually similar to pandas as well, but works on multi-cores. I think pandas works on only single core. Polars works on multi-core. So if you don't have GPU, polars might be faster. In machine learning algorithms, you see, for example, this SVM and TSNE. These two algorithms are actually very inefficient. If you use them on a data with, for example, more than 5,000 samples, you will get, they will not work, mostly, okay? So there is a library called QML, CUDA Machine Learning, that has all these libraries implemented on GPU, and they are incredibly fast. So making them useful again. And the deep learning, we have the mixed precision quantization. I think mentioned that in the Sunday lecture, knowledge distillation as well. Onyx is just a library that converts the model into something that could be speed much faster. Just know the name if you want. We have ensembling. And ensembling, it just means combining several models together, okay? Why does that help? I think I mentioned this videos as well. If you have two models, this making predictions and making errors there, this making predictions and making errors there, okay? So these models are diverse. The more diverse these models are, the better results you are getting. So if I have these two models and average them, look at the R-square, you have 91, 91. Average them might give you 95, okay? So that's why ensemble helps, but when it helps, it does help only when the models are actually diverse. Notice the model here is totally different from the one here. And for example, this might be machine learning, and this might be deep learning. This might be CNN, this might be transformer, for example. So merging different types might help, okay? But for example, if this is CNN, and another one is also CNN, maybe you will not get significant improvement. Yeah. So that's why in ensembling diversity actually matters. There are many types of ensembling. There's averaging, bagging, stacking. Averaging is just averaging. Bagging is taking subsets of the data. You can explore this by yourself. Yeah. Not that important. Now let's come to that choosing the best models. Okay. If you have a real world problem, how would you choose a model? Okay. Let's revisit the data types. We have the data type, we have tabular, time series, waves, text, images, and videos. Okay? Let's have a look at a more high-level approach for these data types. Yani, when you see these data types and I ask you what is the model you are using for this one, what do you say? For example, the image. CNN, text, maybe transformer, right? So what you are linking is you are linking the data types with the model, mostly here, okay? But it's actually, there's a more high-level approach to see these things. It's to link each data type with some sort of property or assumption it has, okay? So in the tabular data, okay, where the columns are independent, not sequential, for example, order of features doesn't matter. So if I have a column that calls, for example, I don't know, the height, and the other one, for example, is the number of floors, it doesn't matter if I put this first or not, or second, yeah, okay? This is tabular. In sequence, order does matter, okay? For example, it's a bit of a hard example, but for time series, yani, you might have data, or in each feature, the first feature represents, for example, 1 day, and the second feature represents the second day. So reversing the order might actually affect the results, because we need them in sequence, because this is the first day, the second day. Taking the second day and put it in the first, it will, yani, I don't know.
Unlike the text.
Yeah, it's somehow like text, but we are doing that in features, yani. This is sort of time series, yani, in time series, okay? But anyway, in sequence, order does matter, okay? We have the neighborhood. Neighborhood is mostly about what we are seeing in the CNN, okay? What do we mean by that? In the CNN, we have a pixel, okay? And we have a pixels around it, right? So if this pixel, for example, represents maybe the eye of a cat, for example, it's part of the eye of the cat, are the surrounding pixels related to this pixel or not? Yes. Okay, so each pixel related to the surrounding pixels, right? And if this property exists in the data you are using, most probably you have neighborhood property, and you will use the neighborhood models. Neighborhood models are actually 1D CNN, 2D CNN, and 3D CNN. It's not only 2D CNN. We just use it for the image, but there are more types of data that could be used in neighborhoods. There are graphs where, like, for example, I think this mostly in the maps, for example, and maybe in biology, I guess. I'm not really skilled in this. There is sequential decision making. It's mostly in a sequence, but there is feedback. After each step, there is a feedback that will change the original model you are using. This is what we call in reinforcement learning. So this is the assumption you can see from this one, and these are the data types that belong to each assumption. The tabular data, the sequence, you have the time series data, we have the text data, and you have the waves data like the audio, for example, okay? In the neighborhood, we have actually the image. In the graph, we have the graphs. Anything that looks like a graph, for example, the maps, because molecule 6 structure. The decision making is mostly the environments like the robots, playing games, and this stuff. And is it clear? Okay, let me ask you a question. Do you see any missing data type here? Images are there in the neighborhood. Videos. Where are the videos?
Video is the combined between images
It could be a combination between them for the videos is the sequence plus neighborhood. We have a neighborhood where each image has the property of neighborhood, but we have a sequence, and each second represents some image, okay? So we have a combination between two properties. We have the neighborhood, which has CNNs, and we have a sequence which has transformers and this stuff. So at the end, you'll find for such problems combined between them. For videos, you use CNN plus sequence models. So CNN might be outputted, then inputted into transformer, for example. For tabular, machine learning is the best models. You can use deep learning, but they will not give you proper results. For sequence, usually the sequence model is SM transformer on CNN. For neighborhood, you have 1D CNN, 2D CNN, 3D CNN. 2D CNN is mostly with the image. It's what we saw by far. 3D CNN is with 3D image it's mostly in the medical field. For example, if you have an image, I just opened my phone and just took an image here. This is 2D image, right? 2D image. In the 3D image, you have something like this, 3D object, okay? You take a picture from each side, okay? Picture from all the sides. So then, if you remember in the image, you have channels, you have batch size, channels, height, and width, right? You will add another dimension, depth, okay? It represents, taking the image from different sides, okay? This is very common in medical images, I guess. So 3D objects, yeah, we call this 3D images, okay? And in this case, we use something called 3D CNN. And in 1D CNN, this is mostly, I think, in the waves. In the waves, we have the data as a line, okay? You can understand that by maybe understand the audio. If I have 1 second of audio, and I just picked small millisecond from this one, is this millisecond related to the previous millisecond and the next millisecond? Imagine you are saying a word, Ahmed, okay? When I say Ahmed, if I just picked a millisecond from the middle, okay? Is this millisecond related to the previous and next? Because it's the same word, so it's related, right? So that's why we have some neighborhood in the sequence itself. Okay, that's why we have 1D CNN. Okay, up to you if you want to, but linking these actually by the problems you are seeing in real world will help you a lot. Now when I see a problem, I firstly try to search for such things. Okay, sometimes the problems are not obvious. I think you didn't encounter hard problems for now. Maybe most of the problems what you encountered are actually very clear, maybe, or straightforward. But sometimes the problems are very hard to define. They are defined into just real world terms, domain terms. Okay, so these sequences, if you found a specific property in the data, you can know the best model to use this one. Okay, this is actually very interesting. It helps me know the best model from just a glance into the data. So as I mentioned, to figure this out, you should do EDA and choose the best appropriate models. Next one is the practical tips and strategies. I will talk about the problems type now. So first is the machine learning models. Okay, machine learning models are actually the best in the tabular data. It's impossible for you to usually repeat machine learning models in most of the tabular data competitions. This has been like this, I think, for more than 10 years. 14 years up to now, I think the green boosting algorithms are still the state of the art. No one could beat them. But for the transformers and text and this stuff, you will find every 1 month you will find new state of the art. Okay, so tabular models has been always the best in linear boosting has been the best in the linear models in the machine learning competitions. You have the linear models. I think you already know them. Linear regression, logistic regression. This is mostly useful when you have linear relationship between the features and target you have, and it's pretty stable. And it is used very widely in time series forecasting. Okay, I think this is maybe the most common use for linear regression, logistic regression. They are not really used in hard competitions, but in reality, I think in anything related to time series forecasting, you will find the linear regression is leading because there's a linear relation in the time itself. If I told you yesterday temperature was 31, okay? The day before yesterday the temperature was 30, for example 30, okay? And I asked you what is the temperature for today? Would you say 50? No, why?
Because it's too far.
Yeah, exactly. It's really related to the previous values, right? You said this maybe intuitively, but if you looked into this like a math, it's like you took a weighted average of the previous days, right? And it's like a linear regression. And you managed to get a very good result. If you said 32, it's very close to the previous days, and it's a very good guess, right? It might be really, really good. So that's why there is an inherent linear relation in any time series forecasting job. Okay, that's why linear regression works very well here. And we have some variants called Arima, Facebook Prophet. These are just variants from linear regression and logistic regression, but they are linear and logistic. But this is maybe the mostly used use case for linear regression. There's the SVM. SVM actually works very well when you have a significant amount of features, but it's very slow when you use it for more than 5,000 samples. How to solve that? It's very slow. We use it for more than 5,000 samples. How to solve that? No.
What's the question?
You have more than 5,000 samples. SVM is incredibly slow. How to make it faster? يعني no. أنا فاهم الكومبريشن لكن بس ما أبغى الإجابة هذه because you're losing information. لا إله إلا الله. هنتكلم عن سكيلين doesn't have GPU support. ما قلت لكم يا أخي QML يا أخي. QML actually for a long while I think SVM was not usable at all for more than 5,000 samples. I think up to just NVIDIA released this QML library, actually. It turns out that we finally managed to use SVM with high number of samples and it gives good results. So that's very interesting, yani. Okay.
Just a quick note about SVM. SVM was the top approach, top model on its time. Like nowadays, everyone was talking about transformers, and when it's first revealed, the SVM was top model on that time.
Yeah, exactly. But due to this limitation, they skipped it for a while. But recently, in the recent years, they found a solution. Yeah, it's very nice. There are the three models we have: the gradient boosting and decision trees, and mostly they are the top. You will, try to open any condition you want in Kaggle, okay, and check the best solutions. You'll find them mostly use gradient boosting, okay. There are several types. XGBoost best balance. I mostly love cat boost because actually it requires minimal work of hyperparameter tuning. I think you will only maybe tune 1 or 2 parameters and get very decent results. LargeGM is good in if you have a lot of data. I remember there was a data where we have more than 1 million samples, and I think 50 features, something like that. Okay, I think I remember I had to rent around 300 gigabyte RAM machine to do that. But if you did that with CatBoost or XGBoost, it will be intractable. So we just used LargeGM, for example, and it worked very well. There are many examples if you want to check these competitions. These are actually called tabular. This is for default prediction, I think, in finance. This is about detecting skin cancer, I guess, from I don't know, medical data. It's about predicting energy behavior, if you had a look at one of them, yeah. This guy is first place. You can see the top. This is the first place in the world, and just use XGBoost. And XGBoost with GRU. GRU is just like the transformer, like I see in the LSTM. So just looking into these three models, what does this tell you about the type of the data? What type of data you have here? Sure?
Yes. Yeah.
Sure?
No sequence data.
الجي ار يو شو يسوي هنا؟ الجي ار يو قلت لك حق سيكونس الجي ار يو you have LSTM, RNN, LSTM, and GRU and transformer. They're all for sequences. So yeah. Well, like gated processing unit. I think they just adjusted the architecture of RNN and just released it as a new architecture. Yeah. It's just a. I guess you should build. Yeah, I think it's there. I guess. I think you have the layers already built in. You can just employ them in end.lstm, I guess, or something, and follow all the libraries. But the point is that from the models, you can know the type of the data. You have time series data somehow, okay? And this solution looks very simple, right? Very simple, but actually, this guy is the third in the world, and he's not simple, yeah. Anyway, Chinese. He's actually leading all the tabular competitions. This guy, whenever he joins a competition or tabular competition, he always gets the first place. But I think he's bad in other sort of tasks. Yeah. We have the deep learning models. Okay, deep learning models are actually the state of the art in everything else except tabular data. Okay, whatever the task you are using, deep learning models are actually the best. Let's talk task by task. We have the NLP. I think we didn't take it much here, so I'm not going into details. But there's something called transformers, which are the leading thing. If you need fine-tuning, you will use something called Diberta. It's mostly the best one. If you don't want to train, you want just to ask a model and give me an answer, you will use LLMs. For example, if I want to classify some essay into whether it's, for example, politics or economy, okay? I can just take it and ask GPT, and it will tell you, whether it's economy or politics, easy. This is called zero-shot learning. Yeah, we don't have to give it any examples and it will still solve the problem, okay? But sometimes we have to fine-tune a model to classify whether this politics, this economy or something. This we call fine-tuning. Fine-tuning models are actually significantly smaller than the zero-shot models. That's why they're good, yani. And for the libraries, there is an architecture called transformer, but there's also a library called transformers, actually, and it's widely used for NLP. And there's a website called Hugging Face. Not sure if you heard about it, but it's a very good website. It hosts all the models you can think of. Has the look here, text generation, image to text, in all formats you want. More than 42, I guess. Audio to text, text to text, visual question answering, document question answering, depth estimation, image classification, segmentation, detection, little more. خلاص. And most of the new models are actually all hosted here. Whenever you open any model, you can see the weights here in the files and versions. In the model card, you can see the details of the model itself and how to use it. Okay, it's a very good website, and it is the leading website for NLP. Most of all the other models of NLP will be hosted here. Yani. That's why it's widely used in NLP competitions. How to improve results with NLP is about your data, tuning your parameters, find model pre-trained on a task similar to what you are predicting now. And for example, if you want to, you have essay of student, okay, and want to assess the grammar of this essay from 1 to 5, okay. Maybe you could take a model that's pre-trained on IELTS exams, for example, okay, and just continue training it on your data. It might give you much better results than training from scratch. Okay, does it make sense? So yeah, and manipulate the architecture embeddings, and this is actually very, very interesting. Very, very interesting. I remember one of the competitions has the same task I mentioned now, is actually you have an essay which has a lot of mistakes by the student, and you want to predict the grammar score, okay? So just imagine the setup. We have essay of a student. It has a lot of mistakes in grammar, mistakes in vocabulary, mistakes in a lot of things. And you want to predict the grammar score of this essay, okay? I'll give you a pre-processing. Tell me, is it the good or not? I will just make a tool that could do spell correction and just pass it to the whole essay. Is it good or not? Sure?
No, it's grammar.
Why not good?
Grammar, because it's spelling, maybe he has good spelling.
Yeah, exactly. No, he might has very bad spelling.
And then you correct it.
But I want to assess the student. You imagine, this is a student who wrote this essay. I want to give him a grammar score, maybe 5 out of 10, for example. Okay? If I improve the spelling, took a tool for a spell checker,
And they give it full mark.
yeah, it will give full mark, right? It's not correct.
The right score.
Yeah, exactly. So I have to use the same essay as this, right? This is look at a very normal setup. Okay. Now, one of the calculators did a very amazing thing. He actually did what? If he took this tool of spell checking, spell fixing, he passed it through the whole essay in order to get the essay that without any spell problems. Okay. He brought a copy of the essay with the spell problem. He has two copies, copy with no spelling problems there, and you have the original copy of spelling problems there. Okay. Now imagine, as a human, forget about AI. If I took the essay with no errors minus the essay with full errors, what will be the result?
Just
The errors, right? So what he did is actually having the two essays, one with spells already checked, okay, and one with no. He took this one, converted to embeddings or features, okay. Took this one, converted into features, subtracted them, and he got the embeddings of the errors, okay. Leave this aside. He took the one with all the spells are already correct, okay, and he fixed the spells. Took the embeddings of the essay with all the spells already corrected, concatenated it with the errors. So instead of the model seeing the essay with errors, okay, he sees two embeddings, one for the essay with no errors, and here are the errors, okay, so learn about them. This actually gives him significant boost in the result. He manipulated the architecture. And it's very, very interesting. ما أدري لو شاكين الحماس يعني. Anyway, it depends on the data and the previous solutions, okay. There are some notes, it's not that important unless you tried them by yourself. For example, if you use a task regression in NLP, for example, for similar to the task I mentioned now, if you use dropout, the loss will be very unstable. That's why this is a very interesting point that you have to disable dropout when using regression in NLP. And transformer needs lower learning rate. I think I mentioned this in the Sunday. Very few ebooks because they are very big. يعني LLMs are training on mostly less than one ebook. يعني some details. The NLP models are very huge. The smallest one is, I guess, the best small only 70 million. CNN, I think the smallest one is maybe 1 million or maybe 500,000. So the NLP models are very big and need some good resources. Okay, and يعني Diberta is mostly used for fine tuning, but recently some new trends came out where you can fine tune an LLM and get better results if the data you are training on are actually generated by LLM as well. But it's not important. There are many examples here you can see. The first two are actually what I mentioned now of the essay scoring. The third one is we have two LLMs, okay? They are competing against each other where they give two responses and you as a user choose one of these one. This is the task outside of the competition, okay? We have two LLMs competing against each other, answering one question, and you as a user, you should choose one of these two models, which one is the best, okay? In Kaggle here, they want you to predict what the model the user will use. So it's like, instead of that, we depend on the human to label which model is better, we want to modulate this into an AI problem. It was very interesting. We have the AI Mathematical Olympiad. I think maybe Kelvin know about it, but it's mostly about very hard AI problems. They are very hard math problems that should be solved by LLMs. You should tune a model to do that, okay? We have LLM science competition. I think it's mostly how to train a model to solve some multiple choices questions. You might see these problems very easy. Yani, maybe you think when just looking here, the solution is very easy. Maybe here I just could maybe use any LLM, tune it and call it a day. Here maybe an LLM call a day. يعني نفس الشيء كده, خلاص? But if you just went into the details and just saw the first solutions, you'll be surprised how complex these things are, how innovative these solutions are, okay, and how much learning you will get from these things are. Yani, you don't expect, I mentioned this again, you are not aware of how much learning you could get by just completing one competition for the full time. But yeah, there are some good baseline codes if you want to return to them. Let's go to the computer vision. In the computer vision, there are some backbones that are known to be the best. It's EfficientNet and ResNet in the CNN. There's in the transformer, you have VET and SWIN. They are known to be the best. There's something called ConvNext. It's somehow hybrid between the CNN and transformer, and it's very good, okay? It depends on the task. I think VET, SWIN, and ConvNext works best with the medical image. This one works with the rest. Yani, it depends on your styles. In the libraries, we have Torch Vision and TIM. They are somehow the same. They have both pre-trained models, but TIM has a very interesting property where you can input any number of channels for the image, okay? Up to now, I think what you dealt with is just grayscale and RGB, okay? But sometimes you want to manipulate this channel to increase the channels, for example, for 10, for example, or more than that. So in Torch Vision, this is not possible at all, but in TIM, it could give you the ability to manipulate the channels as you want. Yani. And implementation, there is augmentation and Torch Vision. Yani, up to you. It's just choices by you, but I like augmentation. Yeah.
What do you suggest for that?
What
do you suggest for that?
For?
Computer vision, right? Is there computer classification, image classification? Will you show image classification?
Yani, maybe, sort of, yeah. For classification, you don't have decision between these for the classification. You mostly want to train all of them to know which one works best for your problem. But based on previous experience, some intuition, maybe if I have medical image, okay, the VIN, SWIN, and ConvNext might work better. Okay, but mostly we will try all of them. Okay. But yeah, no this thing in AI, you have intuition. Most of the choices I mentioned, you have intuition about what might work. But mostly, unless you tried it by yourself, you will not figure out whether it will work or not. Okay? You have classification, efficient, result, VET. Segmentation, you know the unit. Actually, there are many unit architectures used. There's 2D and 3D, but there's 2.5D. Okay? 2.5D is very interesting. Maybe I just don't want to go into much details, but it's like if you have that size, channels, height, width, and depth. This is for 3D, okay? Take the depth and merge it with the channel. So you have that size, channels, height, and width. So it's like you converted a 3D problem into a 2D problem, okay? What I just mentioned now is what we call 2.5D, okay? Let's see if you want to do that. Detection, you have YOLO, as you know before, fast CNN, but there's something called DETR, detection transformer. It's actually very good. But mostly, you will try all of them and check what helps you the best. Yeah. How to improve the results in computer vision is mostly augmentation, time augmentation. I think also I mentioned this in someday, how to choose the augmentation. You will build a model, make predictions of the validation set, check what image the model makes errors on, and based on that, you will choose the augmentation you should use. Okay? And sometimes smaller models work better. Computer vision models are small, you need high learner rate and a high number of epochs. Augmentations can decrease the performance. There are some examples, some are medical. This one is very interesting. I think they have some very old pieces of, I don't know what, but it's like you've been given fragments like this and you want to segment the text on these fragments, actually. This was a very huge competition. It has $1 million as a prize. And actually, after the competition finished, I think they employed these models and managed to read text from very old decades that were not readable before, actually. And it was actually, I think it was very, very common or maybe got famous that day in Twitter, I guess. Even Elon Musk, I think, mentioned, wow, what an achievement, So, ما تكون زهقتوا مني خلاص معلش شوية بس تحملوني شوية خلاص الwaves is like we have it's like the audio, for example, okay? Mostly when you talk about audio you have some sequence, so you expect 1D CNN, okay? This is sorry?
1D CNN exists?
Yeah, why not?
Even if 1D is like tabular data.
No, 1D CNN is not for table data. I just mentioned that before. You can see this page of choosing. Yeah, 1D CNN could be in the sequence, could be in the neighbor as well. Okay, but if you saw the previous one, we use wave data with sequence. So LSTM transformer 1D CNN, but mostly 1D CNN is used for waves. Okay, but the point is, where 1D CNN, because it's a wave, can be used. Okay. But let me tell you something very, very interesting about waves or about audio, is that not 1D CNN can be used only, but we can use 2D CNN like efficiently. What and how can we do that? Okay. Actually, this is very interesting. When I see 2D CNN, it's like I can treat the audio as an image and then make that work. Actually, Actually, image waves or audio can be converted into something called spectrograms. Then we can fit CNN on it. For example, this is audio wave. Okay, we can apply something Fourier transformation or something. It can be converted into something like this. It's called spectrograms. Okay, and we can apply image classification on this. So you can capture audio of someone, which will be like this. Then we will apply some transformation and get something like this, and apply CNN on this one. Okay. Why this matters? Because CNN is very efficient, okay? So it will be very fast, can run in real time. Okay, converting into this maybe would give you bad results, right? Because we are going out from the original data types. But it turns out when you convert to spectrograms and apply CNN, it's actually the SOTA for waves. So to get the best results on audio, you should convert it into image and do classification CNN on image. Okay. والله this is very interesting. مدري نايمين معي ولا تبغى تعطوني كيف كذا لكن. Okay. Basically, imagine now you just you coded this session using audio. Okay. You will get waves. Waves are just numbers over time. Okay. These are the waves. These are the numbers. Okay. In waves there is a sequence because we have time, so we have sequence. Okay. If you have sequence, we should use sequence models, which are 1D CNN, LSTM, transformer, and this stuff, okay? So this is the basic idea. This is how audio should be treated, okay? It turns out if I use some Fourier transformation, to transform this audio into something called Fourier. Yeah, using Fourier, we convert this audio into something called spectrograms. You will get something like this. Okay? A lot of math, but I think it's related to Fourier transformation. It's in mathematics, I think. Function transformation. Yeah, it's Fourier transformation. Yani mathematical rule. Okay? You will just apply it on this one to get this one. If you get this one and apply CNN model on this one, CNN model is to use what the image classified as a cat or a dog. Okay? Use this one in here. You will get better results than when you CNN in there. Okay? So it's very interesting, very interesting, but maybe you are sleeping a bit. Yeah. Anyway, there are many competitions like this. There's Bird Cliff. Actually, they were recording audios of birds in forest, I guess, 200 type of birds, and they are giving you the audios and ask you to build a very efficient model that could do the inference in less than 1 hour, okay? And it could be deployed in mobile phones. So it's very strict and hard competition. Yani you are firstly you should build it so it could fit in a small phone, so you don't have to use high resources. Secondly, it should do the inference very fast, less than 30 minutes. And yani, it's nice. Yani. HMS related to brain activity or something. Yani. Yeah, exactly. Yani, in reality, they will just use the phone, record the audio, it will get into pre-processing and give you which bird is this. It's actually very useful in reality. Yani. Okay? There's proteins and DNA sequences. DNA sequences are just characters, I guess. Yani, you will get a character A, S, 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 madri, شيء زي كذا. So you will treat, يعني in NLP, we have a sentence like Ahmed went to school. So each word is like, we call it token. Okay? In DNA, we have a sequence A, S, 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 I don't know what. We treat each character as a token. Okay? So it's similar to NLP problem. And sometimes you can convert these proteins into some 3D structure like this and treat it as 3D CNN. For example, this will be from different directions. And graph NN as well. There are many competitions like this. AI and security. I'm not sure if you know a bit about security, but this was a bit fun. It was, I think, hosted, I think 1 or 2 years previously. But it has very, very fun, wallah صراحة, task. I think I did some of them, but not all of them. I showed this somewhere. Where is that idea? Okay. Where is your work? They, I think, given 20 or something, any task to do, cluster 1, cluster 2, I don't know. There are some interesting ones. For example, for cluster 2, they just give you a data in some weird format. I think it's numpy something, okay? And they told you this is simple data clustering challenge. Simply submit the number of clusters. Simply. ما سووا لك شيء. أعطيك داتا بيس 683 صف 542 features. خلاص؟ They give you data with 600 samples and 500 features. I ask you to just submit the number of clusters. So what I did is taking these features, apply T-SNE to decrease to 2 dimensions, and just plot it, and got this. Okay, so the number of clusters is 4. Right? So just the next step, the next challenge was actually, they told you a lot of story here. The data we gave you actually contains embeddings, which are features extracted from somewhere, and they are associated tokens. They give you 500 columns, and for each column they have a character here in that line, A, S, L, something like that. Okay? So they told you that these tokens could consist of the flag which what you are searching for. Okay, so I just tried to read the characters from the data, but I couldn't. So the trick was to put the characters on the same plot as we did before. Okay, and try to zoom in. Coordinates are 19582. So yeah, it was funny, Then if you read here, I think they have. Last word is time. Okay, so when I use that in the flag submission, use time and put question mark and enter, the output was very weird number like this, like this. So I didn't know what this is. So it turns out this is time in Unix, and just replace time with where is it? And then replace time استفهام with flag question mark. Actually, give me a flag. There are many other complex tasks like granny here. It's just not downloading, but it's like how to fool a network. If you have a network that actually classify successfully cat or dogs, okay, how to fool it in order to misclassify this by changing the data image. Actually, this is very important in security, not here, yani. But yani, a lot of other stuff, how to fool an LLM in order to give you the flag, yani. How to manipulate image, yani. Some fun stuff, yani. But anyway, if you want to approach any competitions, I think I prefer to firstly start reading the discussions and codes, okay, and summarize them well. Actually, that's what I do. Yani, whenever I start a new competition, I actually have whole notes here. Maybe for this one, I just started with this recently, and just by reading the discussion, I summarize the problem itself firstly, okay, then try to brainstorm ideas where could improvement come from. Just in last week, I just summarize all these. Okay, so you are saying 3 months are a lot. Do you think you can experience all this in 3 months? Actually, maybe you will not even complete all of them, okay? But might be one of them, okay, directly give you the gold. And this happens before actually, okay? So you keep trying, and whenever trying something new, you will learn a lot. Yani some of these actually require new architecture, some of these require some new laws to rewrite, okay? So it's very fun to experience with this and actually learn new stuff, yani, okay? So, sorry? اكيد ما خلاص قربت انتهي. وطبعا كتبوا لنا شيء ذا don't forget to eat and sleep. اتذكر في واحده من المسابقات يعني one of the competitions, and actually I remember I forgot to eat and sleep. That was a very hard month. Wallahi, I was really dating that one. I think in one session I think I sat from after Isha up to the Fajr 8 or 9 hours straight. I can't stand يعني الله يستر على صحتي. Last note is there a difference between what you see in Kaggle competitions and real world projects? Actually there is. The problem definition itself, yani, we have a problem here, okay? Yani, here we have a specific problem that is defined, and they ask you to build a model, okay? But in reality, they just give the domain knowledge, for example, ask you to define the problem yourself. Actually, you will learn these skills as you go in Kaggle, if you practice a lot, okay? And data availability, you might be asked to gather the data by yourself. Model deployment, after you train the model, deploy it on a device or the internet or something, okay? Evaluation metric, we have here the evaluation already set up. Yani maybe you study only 2 or 3 evaluation metrics by far, but there are quite a lot, okay? And it's also a resource and time constraint. Sometimes you just want to fit 70 billion LM and call it a day, and easy. Like sometimes in reality, they want to fit this model into a phone, and 70 billion is not possible, for example. So I think Kaggle is a very good start for knowing the core of AI. But after that, you'll maybe spend several months learning these things. Then I think you'll be getting very unique skills against your competitors. Yani. Here, final again is should I use GPT or not? Okay. Actually, don't expect if you just use GPT and give solution, you will win the first place. خلاص. It's need much more than that. But if you want my opinion about whether you should use GPT or not, for my opinion, I think you should use it extensively, but with 2 rules. Firstly, don't copy, just write. Okay. Second rule is don't write something you don't understand. Okay. If you do this for several months at the beginning, okay, then after that, I believe you can copy them. And maybe after mastering this basic, after that you can copy, but you should have some time where you write the code by yourself or manipulate the code by yourself. Okay. And even the codes in Kaggle, if you start a new competition, there is a code somewhere. Try to rewrite this code. Maybe you will spend 1 week doing that, but you will learn a lot, okay? For me, when I join a new competition, it has 3 months of period. I usually spend the 2 first competitions individually, okay? I try to rewrite the pipeline by myself, learn the knowledge by myself, and all this stuff. Then in the last week, I team up to get our solution combined. Sorry, last 3 slides. In AI, we have several career detections as well. There's the research path and industry path. In research, you are mostly working on the architectures themselves, I guess, and trial new architectures, manipulate the previous architectures, I guess. Working mostly on paper stuff, okay? research and development. And in the industry, you mostly will use existing tools or existing models and try to apply them to real-world problems. Okay, there are two different paths, and each one has some good work environments. The research, you have the labs of universities and AI labs like OpenAI, DeepMind, and this stuff. In the industry, mostly are companies, tech giants. I think most of the startups and companies are using Apply AI. For me, most of the guys, senior guys I know, actually went to the research path. They are really good. I think most of them were seniors of me at university, but they went to very good lab. I know many of them went to DeepMind, many of them went to Microsoft, mashallah. So if I could give an advice at the end, maybe it's firstly regarding later how to, if you want to find a job or something, what would you need? I believe you need two things. You need skills and you need connections as well. Skills, I believe, maybe you will ask me whether Kaggle will provide me with a job, for example. Okay, I could say that Kaggle will provide you mostly with good skills, very unique skills you will not find everywhere in the courses or something. But connections, you have to build them by yourselves outside Kaggle. For me, how did I build connections? Trust me, LinkedIn is not that useful. I just post on LinkedIn to tell people I'm still alive. But most of the connections I actually got maybe from university. My friends at university, the senior students at the university actually were very skilled in AI, and most of them went to very big labs outside. So they actually helped me a lot. They helped me mentoring at the beginning, and then they provide me with very good recommendations and opportunities. For me, maybe like summer schools like this, I actually met a lot of great people here and the previous year. And most of the opportunities I actually got from no, not KAUST, مو KAUST. I mean most of the opportunity, most of the connections. Where did I got most of the very useful connections for me? جو من وين؟ خلاص السؤال هنا. No, never. Kaggle actually learned unique bout of skills. Okay, when applied these skills in real world, most of the people were very impressed about the results. But I'm not talking about the skills. Okay, we need very good connections, not Kaggle. No. Huh?
No, I think when they see your results and your work.
Sorry?
When they see your work and results, they would hire you.
Yes, sort of, but not really.
Okay, KAUST Academy.
No. Actually, most of connections that were very useful to me came from teaching. Since I started AI, I think in Sudan, I was presenting a lot of lectures. Maybe I didn't understand anything except table data, but I go and explain something to people in the university. I remember one session when I barely understand transformers. Okay, they asked me to present a session at the university. I said, okay, at the university it should be okay. But I found that it is to be, I think the Ministry of Education in Sudan, I think most of the professors, who were in vacation outside Sudan, they all came that day, okay? And I barely understand transformer. And all of them are professors in math, professors, NAS, very good experience, very deep experience, maybe 30 years in math, 40 years in math, wrote a lot of materials, wrote a lot of books. They just attended that session. Allah, it was very hard, But it was very useful in giving connections. Since then, I think many people reach out to me because when you do teaching, you show people that you are understanding what you are doing, okay? And when you do that, most people will hire you easily, okay?
Just a quick note about the teaching. Actually, when you teach something, actually you learn a lot. So I really suggest you, if you try to learn something, after learning as a practice, you should teach someone. During my master's degree, I was studying my master's degree. Actually, I was teaching in one of the college. So, when my master's degree, when they revealed the curriculum of the next semester, I was going to my department in my college and asking, I'm gonna teach these courses, which is the same with my master's degree. So I'm learning something from my university, and I'm teaching day after tomorrow. I was teaching on that. It's a really good experience to learn.
Yeah. And actually, maybe one more note is if you have very good skills and no connections, okay, you will mostly get a job that is very underpaid, yani, than your skills, okay? And if you have very good connections and you have no skills, you'll mostly not benefit from these connections, mostly, okay? But if you have both, you could get to places you do not expect, yani. For example, I know most of the people in my university were actually very normal people, yani. They barely started maybe AI 6 months ago or something. And after some months, I just found them in Google DeepMind, someone in MIT, someone in Harvard. Yani, when I just investigated this a bit, I found I have a lot of seniors who are already there, okay? So they just recommended them, easy, okay? So I think if you want to really reach good places, you should have good connections. And as I mentioned, I don't mean LinkedIn, I mean connections that you make from any professional relation, yani, for example, from making a competition, working with someone in competition, working on someone hackathon, working on someone on some paper. If, for example, you joined a hackathon and you have some teammates who are actually business guys, not technical guys, okay? Maybe even if you lost that in hackathon, but maybe after 3 months, that guy will remember you are very skilled in AI, and he might recommend you to some very good lab, okay? Actually, this happened with me. I think I remember maybe after 1 year after I started the AI, okay, I won one local competition in Sudan, and someone just sent me a message after that. Are you interested in working with me and in freelancing in some distance? I said, okay, it's my first time trying this, so why not? Okay. I said, okay, and met him in some meeting. I found him actually is principal data scientist in a very big lab in America. Okay, he's Sudanese. So, and it was really fun to work with him, I think for several months. After some time, he told me, AI is going very fast. Why not have some session together where we revise some papers, for example? I said, okay, so, but I will do the sessions. Why? Because I want to learn, okay? So I just prepared the same transformer session I did before and want to represent here, okay? He told me, okay, I'll bring my friend to attend with us in the meeting. I just said, okay, I thought his friend maybe in the university or something. And I think he's called Ahmed. So they were two, and I'm the one who presenting. I presented, I think, for 1 or 2 hours straight, okay? And I think maybe it was not the best. But I found out that the one who has been brought out was a very big professor in the University of Pennsylvania in America. And after that, this guy told me, I want you in my research. Okay? I said, okay, why not? After 3 months, I joined his research remotely, okay? And he told me, we have a meeting today. I said, yes, okay. I just attended the meeting, and he told me, we will bring some mentors for you from MIT. So if you want any recommendation or want to master here, he will give you recommendations if you want. So notice how it started, and notice where it ended. So actually, this not happened with me only. I was exactly seeing if this happens with everyone, and many of my friends actually has the same experience. Mostly at the beginning, you will not the connections will not be very, very useful, but at some point, all of the connections will be incredibly useful to give you very good places. But you need what? You need skills. Okay, that's why you have to build skills and connections at the same time. If you have skills and got connections, you could get to very good places. So at the beginning, don't focus too much in research or industry. I suggest to learn both. Try to participate in both. If you have any opportunity to participate in research, try to do. Industry, try to do. Okay. Up to some point, after to get some experience in AI, you will find yourself, I want to go into research. I want to go into industry. Okay. But if you just start AI, I suggest to go into both at the same time. And hands-on project. If you want to learn bacterial, go to Kaggle. بس هذا الاختصار خلاص. I think that's the best thing. Networking, attending workshops, conferences, and this thing is very useful. So, what do you think of the announcement? Campus KQ. Oh, from the next week, we will replace one of the periods of the lab or enrichments. okay, for 3 or 5 hours. I think mostly on Thursday, I hope. Okay, so let's see who is the best. بعد كده شدوا حيلكم خلاص. But it's actually the main purpose. I think the lab itself, if you just try to work on a lab for maybe half an hour, do you see a big difference in your skill before and after? Not really. Yani half an hour of a lab, not really. Okay, because maybe you are just filling gaps or something. But trying to solve a problem from scratch, or writing the code by yourself, or at least copying the code but understanding, structuring the code to work by yourself. Okay, this will help you a lot. It's not too much, maybe 4 or 5 hours per week, yani. Maybe we'll take one of the lab enrichment period. But I hope it will be useful for you to learn hands-on experience, yani. So stay tuned, I hope it goes well, inshallah. Thank you for attending. Jazakumullah khairan. It was a pleasure to be here. I think I'm leaving to Abha on Saturday, inshallah, yani. Sorry for that. I don't think so. They don't have good heads. I'm going to be the head of the year, inshallah. But if you have anything with your projects or something, you can just send me a message or something. I'm willing to help. Actually, I'm not good in giving you ideas, and don't ask me about ideas. But if you got an idea and want to know which models are best, is this model good or not? Is this idea good or not? I want it more efficient, want more performance, something like that. I think I can help with that a lot, yani. Formulate real-world problems into air problems. I can help with that. But giving you real-world problems, I can't, okay? So if you have any questions or something here in WhatsApp, anyone want to press that call button 60 times, it's okay. Just send me, yani. And jazakumullahu khairan. Assalamu alaikum wa rahmatullahi wa barakatuh.